Hello everyone. Am I audible? Okay, just wait for a couple of minutes. I'll share my screen. Okay, just hold on a bit. Where is my presentation? Just hold on. Is the screen visible now? Just hold on. I guess. Wait. I think there is some kind of problem right now. Okay, is it visible now?
Yes, sir. Visible.
Oh, thank you. So let's. I think we have sufficient number of students over here. We can start. Okay. So hello guys. Welcome everyone. My name is Shantanu Chandra. I'll be your instructor today, and today we are going to discuss about the basic of blockchain development. Okay. So there are a couple of things which we like to discuss, like what is blockchain, how it works, and what are the basic fundamentals, so that you can start understanding what blockchain is all about. And recently, most of you have heard about blockchain. If you haven't, then you will go through the newspaper and you will see that there is a lot going on in this blockchain space, and it has always been there since a couple of years. Blockchain is quite intriguing for like a couple of organizations, and maybe more, like that number is increasing day by day. So this session, let's talk about this session first. Okay, this session is basically about this is going to be a one-to-one interaction, not one-to-one, but I want the session to be as interactive as possible. Okay, so first, you guys, every one of you, whoever is there, is requested to ask questions, as many questions as you want. You can directly ask your questions. If that question is really relevant, or it feels like others will also be benefited from that, I'll try to solve it out over here. If not, then I'll give you something brief about it, so that it gets solved, kind of. So my idea here is for you guys to develop a basic understanding of blockchain. Since this is kind of our first interaction, let's get to know each other first. So I'm Shantanu Chandra. My name is Shantanu Chandra, as it is evident over here. So, and I am actually a blockchain architect. So, you might be wondering what's the role of the person who is blockchain architect. It is basically designing a solution which involves blockchain into it. Okay, let's say there is a use case, and there is an existing traditional solution which is non-blockchain based solution, and somebody is looking forward to either integrate it or design it from scratch. Then the person who is going to be responsible for that is either like a blockchain architect or a senior architect or somewhere like that. So my role is pretty much like designing the solution and helping in implementation. So sometimes, this is a green field, rather blockchain is a green field area. So you may have to work a lot on that. So it depends upon your experience and your understanding of enterprise applications, whether you can go for like a blockchain developer or a blockchain architect or like lead developer. Like it depends upon your understanding, okay, of both things, like blockchain as well as the enterprise solutions. So it could be anything. It could be a CRM. It could be a development experience on like non-CRM based stuff, maybe mobile application also. But even if you have experience into designing and all, then your role in the company will be decided based on that. Okay, that's enough about me. So I would like to know how many of you are from programming background. Just say yes or no. That would suffice. And okay, great. Okay, so I saw like 3 no over here. So I just want to know whether you guys are into this into this IT industry or from non-IT industry. Okay, so you guys are from IT industry. That means you have seen somewhere programming thing, and I see one non-IT. So, like, if you, Prashant, can you let me know, like, what type of industry you are from? Oh, great. That's banking is more of like, the first validated use case. What about you, Mohit? What's your core industry right now? ONGC, oil and gas, oil and natural gas, basically. So, okay, that's great. So, the thing is, like, if you are into this blockchain space, first of all, you have to understand what blockchain is all about. Okay, even if you are coming from non-IT background or maybe from non-programming background, there is a lot for you over here. It is not like that this is end of road. That's great. Muzammil, you have like a good, there are many use cases over here for banking. So you are perfectly at the right place if you want to, grow in your career in terms of, because things are changing right now. A lot is changing right now. So let's talk about it, like what blockchain is all about. And, recently you must have heard about Bitcoin, and, the price is, people are getting interested into it, and a lot of investment is going on. People are getting lots and lots of stuff. Apart from that chaos, there are many great things which are going in blockchain. There are a couple of new protocols which are coming. There are a couple of projects which actually solve some problems are being presented into the blockchain space. Let's say, for example, Bitcoin was trying to solve one very crucial problem, like transfer of funds without intermediaries. So it was a very good use case because because of intermediaries, you have to pay a lot of you have to waste a lot of time. Let's say if you have to transfer money from India to let's say any other country, then you have to go through a couple of channels, and those channels have their own time of settlement. So and because of that, actually there are not just time challenges, but due to since these systems are not directly related to each other, there can be a security hazard also. It is not like these systems are not safe, but there are things because of which these systems are, since these systems are separate from each other, there can be a problem in between. Let's say we talk about Swift. Okay, Prashant, thanks for mentioning it. Swift is basically used for international, fund transfer. So, like, it is kind of, you can call it, those who are not from banking background, you might not have heard about it, but Swift is basically for settling international payment. Okay, so let's say it is kind of, settlement between countries also, or maybe countries to supplier, countries to countries. Like, there are a lot of things are going on in Swift even, but mostly it is used for, not mostly, but every time it is used for international settlements. Okay, and but for every international settlement, there is a copy which is there in the local networks. Like if it is a banking network, it is then that kind of data is there on the banking channels also, the local banking channels. Let's say you have to do a transfer between not every, and the most important thing is not every branch is for Swift settlement. So it depends upon the branches also, like who is entitled for Swift settlement. And then there is like another challenge, because since these channels are separated from each other, there's a lot of human intervention involved. And there were a couple of things because of which this combination of system, I'm not saying these systems are inefficient or something, but the combination of these actually led to many problems. So there was one incident in which the hackers took advantage of holidays. Can you believe that? To exploit the international settlement system, hackers exploited the holidays. How they did that? Like the case was in Bangladesh, and it was the attack was organized by Lazarus, I think. I'm not sure, but it was kind of revealed in investigation that it was Lazarus. So the case was, how they were able to you can say, like, exploit the system in Bangladesh. Since it is Islamic country, there are the weekends are actually Friday and Saturday. Like in Saudi Arabia and other Islamic countries, weekend is in Friday and Saturday. And Swift settlements take place in US, kind of, because it depends where the company has an account. So most of the time they have some accounts in some US banks. So in US, Sunday is holiday. And let's say if by any chance there is a holiday on Monday somewhere, then you can imagine, like, before anyone knows, there are and there could be a lack of communication also, because people tend people are not very swift in responding on holidays. So if automated system is not able to flag couple of things, then it could lead to disaster like this. So, and it happened in the Bank of Bangladesh, and it was somewhere around 995 million fraud, which somehow was mitigated to couple of millions only, like some 70 or 80 millions. So it was it was very large scale attack on Bank of Bangladesh, I guess. And people, though the system was fine, it was perfectly all right, but due to a lot of human intervention in validation and verifications, things it was really disastrous. So it is not like these systems are bad, but sometimes these systems actually lag in term of efficiency. So this was just an example of our current banking system. So and we will try to and let's say if we are using some payment channel like Bitcoin, if there is a settlement, that settlement could be done in like couple of blocks, maybe in 1 hour you can, or maybe in 30 minutes you can get the resolution of your problem of fund transfer. That's it. I'm not saying that it is perfect, it is perfectly safe, but it is a channel. Now coming back to the Bitcoin and stuff which is going on right now. So can anybody tell me why there is so much increase in price? Why everybody is getting interested into this Bitcoin and stuff? Can anybody tell me why people are so much interested? Like why the price is jumping so much? Just I want to know your opinions. Okay, that could be a reason. Okay, that could also be a reason. Yes. Okay, that can also be a reason, Prashant. Yeah. Speculations. Okay, that's great. Transparency. Okay. What about others? Come on. You must be having something in your mind. Billionaires trusting on Bitcoin. Yeah, maybe. Independent of dollar value changes. Okay, could be a reason. Okay, yeah. Immutable. Okay, that's kind of that's the inherent property of blockchain, so we need not to worry about that. So there's no governing body. People like it, investing and supporting it. Okay. So let's try to understand it from a technical perspective. Why there's so much people are trying to understand blockchain. It is not like everybody is investing in cryptocurrency. Okay, but sometimes people are investing in cryptocurrencies. Sometimes they are building up like a team or organizations based on blockchain, which may not be public blockchain or cryptocurrency. So what's the idea behind that? So just think about it. Right now, we take internet for granted completely. Okay. There were a couple of things a few years back, not few years back, but rather 20, 25 years back, which were not possible. These are possible because of internet only. Like, there were alternates like we could do a lot of things, but internet was in very nascent stage. Like in 1994 or 93, when it was email system were introduced for general public, it was more like they were confused, like how to use the symbol and what the hell is this all about. So the reason is like every time new technology comes, there is a buzz around it. Okay, and that buzz actually is not about the technology, but it is more about fear of missing out. And if we go back, couple of years back, you will see that every time new technology comes, people actually try to do the litmus test. Okay, so you will see that every time people are trying to be more and more aware of this technology, it takes a surge. Okay, so this is a phenomena which leads to mass adoption. Okay, so my question now is, how many of you have heard about Bitcoin or blockchain before like 2015? I can see a lot of no, and there are a couple of yes also. So I'm really interested in knowing those who have said yes. So what was the news which came to you in Like, let's say it is 2014, okay, and what was the news which which you heard, so that you understand, like, there is something called Bitcoin, or there is something called blockchain. Come on, guys, those who have said yes, just answer this question. There must be a news, or how can you know about Bitcoin in 2014 or 15? Okay, you heard about mining. Okay, Bitcoin mining. Okay, what about others? Let's take a couple of years more back. Okay, and the year is 2012. How many of you have heard about Bitcoin in 2012? Those who said yes, have you heard about Bitcoin in 2012? Anyone? Yes? Anyone? Come on. How many of you have heard about dark web? How many of you have heard about dark web in, let's say, 2012 or 11? Anyone who has heard about dark web in 2012? Just say yes and your ear. Because, knowledge comes to everyone, in different chunks, because, not every life is same. So if you have heard about dark web before, let's say in 2012 only, just mention yes and the year, which you have heard first about the dark web. Okay, that's great. So, in 2012, 13, people were actually interested in, dark web, let's say, because for every person, it is going to be different. It is not like, uh, okay, the thing is, we have a kind of protagonist syndrome, everyone, like when where we feel like, most of the things existed after we knew about it. So, but that is not the thing. So actually, dark web existed, before our actual internet. So dark web is basically which you are not able to access through your search engines and all, but most of the data is there in dark web. That is not directly accessible. Okay, that is there is dark web and there is deep web, and there are a couple of things involved in that. But the idea is, most of the time, it is communication between secure servers, or mutual communication, and sometimes it is traceable, sometimes it is not. There are a couple of things through which we can access it, and there are a couple of things through which we not through which, but which we can get from dark web. So there was a dark web website founded in 2011. It was called Silk Road. You could get mercenaries on demand. You could get anything on demand at that time, and there was a huge operation in between, and Bitcoin was like used as native currency. Okay, so I heard first about Bitcoin in 2011 and 12 somewhere, because I heard about this website Silk Road. Okay, and Silk Road was actually a very dangerous kind of website. But if you are into the forums and all, then you will know about these things. Or if you are even slightly interested in using hacking tools and all, then you might have heard about Silk Road and all. Because most of the time, whenever your credentials are stolen, they end up in dark web. That's the fact. Whatever is stolen from your system, you may not know it, but it might end up in, in dark web. So, there are, it is kind of a parallel internet e-commerce economy, which is there. Okay, so, when you are into these kind of things, you actually came to know about, these kind of payment technologies first, because I heard about Bitcoin at that time, and then, there was another incident, and then, people were developing interest, but, I was not aware how to get it because it was very cheap at that time. But since it was involved in a racket at that time, I was more like afraid of, studying more about it. I thought that it could be an internet bomb or something, like, I'm going through it and, somebody might knock up at your door and say you are under arrest. I was like, totally afraid of Bitcoin at that time. Though I heard about it, but I was afraid of it. So, these kind of things actually happen with most of the technologies. Okay. When these things happen, these things come into, like you can say, like these things actually make the public aware about existence of the technology, because that news is kind of a sensationalized news. Okay, and people tend to grab that sensation. They want to, know more about it. Then, gradually, every time, when you hear about these kind of things, like, okay, in 2017 again, there was like a huge bubble. What we call it, it was a bubble, and people started knowing about it, and there was a lot of highs and lows in that, and again we are passing through this same phase, and this is not for the first time we are passing through this phase. It is like, in every like couple of years there is a market cycle in which the price goes up and then it goes down and then it leaves it to previous mark and then goes up. So these things actually are, we call it like bubble, or sometimes we call it a lot of things, but these bubbles are actually supported by something, and they are supported by, while the technology, while the bubble is growing, it is supported by fear of missing out. And when this bubble settles, it is not like it is busting. To be very frank, I'm not saying it is going to bust or whatever. It settles down to a size. If it is a bubble, then it is not busting. If it is busting, then it could go to like $1 right away. That's called bubble bust. But if it is not busting, that means it is contracting and expanding. Okay. So year on, you will see, like, there are a couple of people who actually support it. They try to build something on it and then they cling to it. Like, okay, this is my, let's say there is an entrepreneur who want to, create anonymous cryptocurrency. Okay. He did that and then he cling to it. At that point, now people have access to anonymous cryptocurrency and, they can actually use it. So, once these things happen, once these bubbles happen, or, bubble expand rather, you get something which is good for it. The only thing which drives the bubble is fear of missing out. So why the why the companies are investing into it? Nobody wants to miss out. That's why it is called FOMO. FOMO means fear of missing out. And, it's good for everyone who is related to blockchain. I'm not talking about crypto investors. I'm talking about the developers, the architects, and the ecosystem around the blockchain. Every time it expands, it has to be, a solution. Like in .com bubble, what happened was everything was online. People were trying to sell everything online. We used to call it .com bubble. Okay, like even if it is a dog walker, then they have a website and something like that. But now you see, that thing has become part of our life. If you want to know more about the dot-com bubble or any other technological bubble, then just, study about it. And you will see, whatever we call that bubble at that time, it is just like overvaluation. After some times, it settles to its value, and or maybe it becomes more valuable. It becomes more valuable, and still, it is being used the same way it used to be at that time. The event which we call bubble bust. So, this happens with most of the technology. But when people suddenly start becoming aware of things, they tend to tinker around it, and sometimes things fail and sometimes they succeed. So these kind of phenomena happen right now. Everybody is trying to be a part of it. So that's the reason for the so much fluctuation in the price of Bitcoin. Now, with interest comes couple of things. Like, you could have attacks on blockchain. Like, there are blockchains which can be attacked very easily. Then, people. How many of you have heard about that recent? There is a wallet company. Okay, how many of you have heard about Coinbase? What about others? Okay, so I would recommend the first thing. So, first takeaway from this session should be, you have to be aware of developments in the blockchain space. Either you subscribe to those news channels or news portals, or go through them medium, and there are a couple of channels through which you can get your blockchain related stuff. So I would highly recommend you guys to actually get aware of the blockchain space. Like, what are the things which are going on? Okay, so Coinbase is an organization which basically deals with cryptocurrency, and it is said to be going for I would rather say an organization. It's not an exchange. We'll talk about it later sometime, but it's an organization, Coinbase, and they actually are going for public listing. And before that public listing, their valuation is supposed to be somewhere around 100 billion. How many of you are aware of that? Okay. So go through it. It's good news for everyone here, because as these organizations see legitimacy, like people accept them as, or government organizations, or SEC, for being to be very specific, SEC, like Security and Exchange Commission of US, and if they find these kind of organizations to be legit, then we have a kind of a mass adoption of this technology. If there is mass adoption, there are a lot of jobs which are coming. If you are technical, non-technical, if you know blockchain, if you understand blockchain, you can explain it to others, that's also a job. Because there are a lot of people who don't know about blockchain but still want to understand blockchain. So you can do that also. So the thing here is, these bubbles, these acceptance, and these phenomena are actually very helpful for this blockchain community. Okay, we will talk about wallets also. Okay, and Indian government has its own take on blockchain. We will try to talk about that also. Okay, then we will talk about private, public, and consortium blockchain. These are just types of blockchain, or it depends on a couple of things, but we will talk about them. So let's understand the wallet first. Okay, so what is a wallet? So how many of you have heard about public key and private key. Okay, that's great. That's actually great. So it makes it very easier for. Is there any no here who does not know about public key and private key? I can see all of it is yes. Okay, so let's try to understand like what public key is. Okay, for that we have a example website. So let me show you. This is actually a very good website, and I like it. It has a very important thing which I can show you right now. So you know, let's say I'm trying to generate a wallet. Basically, what is a wallet? So a wallet is the way or a program which can be used to keep the private key in blockchain. In any blockchain, if we talk about any blockchain, then basically we establish our identification by showing the ownership of private key in any blockchain. Whatever blockchain are we talking about, we actually focus on establishing our identity using private key. Why it is important? Because the guessing of private key is kind of impossible. Okay, why it is impossible, we may talk about it in later class, but right now you can assume it is kind of impossible to guess private key. Okay, why? Because there is a combination of private key, public key, and like, so let's understand what private key is basically. So if we talk about any encryption algorithm, so private key is basically a number. Okay, but it's a very large number, and that too it's a prime number. And everybody knows, like, prime numbers are very random. And if we talk about prime numbers, large prime numbers, then it is quite impossible to guess. So sometimes if we talk about the size of prime number, it could be like 256 bits. Can you like it is if it is 256 bit, that is just the representation. Hexadecimal is just representation. You can represent any number of bits in form of hex. If you divide it by 16, you will get the hexadecimal values. Okay, so 256 bit means 2 to the power 256. Okay, so let's say how many I'm giving you a task right now to understand the importance of prime numbers first over here. How many prime numbers are between 5 lakh and 6 lakh? That means 5 lakh and 6. Can anybody tell me right now? Or what would be your approach if you want to find out how many prime numbers are between 5 lakhs and 6 lakh? Is there any other way out? Like, what could be, obviously, if you are talking about programming, then you'll write code and count, but what would be your approach? How would you do it? Google it? Who is stopping you from that? Google it and let me know. World of prime numbers is really very interesting. It should be multiplied by itself. No, then it is power or it is exponent. If a number is multiplied by itself, then it is exponent. It is not prime number. A prime number is basically a number which can be divided by itself only. Try to Google it if you can. The thing is, most of the time you have to follow some algorithmic patterns. No, every number can be divided by itself, but a prime number can only be divided by itself. Okay, so I got one answer here, like 5 lakh to 6 lakh, and see if it is divided by itself. So how many loops are we expecting over here? Let's talk a little bit about computation, because like I can see most of you guys are saying that okay, this is going to be a computation. So how many loops are we expecting over here? Okay, now let's suppose the prime number I'm talking about, like 1 into 1 multiplied by 2 to the power 56. Okay, and 5 multiplied by 5 multiplied by 2 to the power 256, or maybe let's say 255. How many iterations are we looking forward for here? Just to find the prime numbers. So what I'm trying to show you here is, the approach you have taken is kind of a brute force approach. Okay, and with brute force approach, we have one problem. And the problem is, if we talk about the problem, then it could be like it can lead to anything. Like this is like, we are talking about lots and lots of, if we are talking about 1 lakh loops, and then we are talking about in power of 10 to the power 18, 19, 20, then this is actually brute force itself is not feasible. Okay, so we try to do it, in different ways. There are many ways to do it, but there are limitations to it. So what we do usually is we actually work on these prime numbers, and it is actually, if we take the prime number large enough, then it becomes very hard to guess, even to compute. If we are talking about 10 to the power 5, if we talk about this range, it is 10 to the power 5. But this one, like, 2 to the power 55 is of the range 10 to the power maybe 78, 80, somewhere around that. You can imagine like how big that number is going to be. And if you want to find all the prime numbers, that is practically impossible to do that. Okay, so there are things like which you can do with the prime numbers, but if we have to even remember that prime number, that is kind of an impossible task. Let's say you found that prime number, okay, and you will find it almost impossible to remember that prime number. Why I am saying that? Let's say I am going to generate a similar prime number. Okay, let's say for 12, generate a prime number, and that prime number will look something like this. See, can you remember this number, guys? Everybody can see my screen, now. If you can't, just let me know. Okay. So can any one of you can remember this prime number? This is the prime number with hexadecimal representation, of course, where somebody mentioned that. Okay. Can anybody remember this prime number? Is there any way you think of, like, you can remember this prime number right now? So what if I say that there is a way? Because this prime number is actually a representation of these English words, simple 12 English words. Let's make it a bit simpler. I'm trying to, make it like 6 only. That's fine. So for 6, it again a prime number of same size. Okay, but you can remember this. Am I right? Venture, fantasy, scrub, swarm, token, treat. That's pretty easy. And to use these kind of representations, there are some operations which are actually done to these words which lead to this prime number. Okay, these are actually very easy to crack. But yeah, we can see like there is a way through which you can actually remember your prime number, or you can actually think about your prime number. Like, it can be comprehended. If I'm saying prime number, then you won't be able to remember this. But if I am saying these words, you will be able to remember this. So basically, these words are called mnemonics. Okay, mnemonic means memory tools, like related to your memory, so that you can actually recall these numbers, or maybe you can recall your private key. So what a wallet is? Wallet is just a tool in which you are going to keep this. Okay. So this is just the simplified version of it. But when we after these sessions, you are going to have your career session. So in career sessions, we will talk about Ethereum also. So we will see these keys in action. Okay, how they are generated, and there are a couple of things related to wallet. The first thing is sometimes wallet are deterministic. Okay, deterministic means you can actually recall the wallet very easily, like in case of our these mnemonic words. But mnemonics are actually considered unsafe because it may be leaked directly. So people use hardware wallets also, non-deterministic hardware wallet. So non-deterministic wallets are basically when once the public key has been generated, it cannot be generated again. Once the private key is generated, it cannot be generated or regenerated. So you have to keep your private key stored in that memory. So these wallets are somewhat like secured pen drive, you can call it, and they keep your private keys. And a lot of things are there in wallets, but the most common thing is the wallet keeps the private key safe. It can be any method to do that. They may be using some deterministic wallet, or maybe some non-deterministic wallet. Non-deterministic means, as I told you guys, like you cannot regenerate the private key. Most of the time it is generated only once. Okay, so example of non-deterministic wallet is when you are connecting to Ethereum, then there is a library called Web3.js. Okay, and Web3.js can actually generate only one time. But you might be wondering, okay, why this is so? How can this be so random? But it depends upon the algorithm, and these numbers are it is mostly like you are selecting a number in your from your algorithm, which you consider is random. Okay, that's the thing. Like you are just selecting a random number from your algorithm, and if your algorithm somehow is BIP39 based or somewhere like that, you could be using a very big number, which is like 2 to the power 256, in the range of 2 to the power 256, which is obviously, you can understand, like it's huge. Okay, it is somewhere around 78 digits number. So this is a little bit introduction to the wallets. So why do we need wallets? We need wallet to have our private key secured. It could be our mnemonic keys, through mnemonic keys, or through basically mnemonic keys are deterministic wallet, and there are like Web3.js, it gives you like non-deterministic wallet, but you have to actually keep the private key, otherwise it will not be generated again. Okay, so what you do is you either keep it as a copy in somewhere, or you want to keep it in secure thumb drive like things, and these are called ledger wallets. Okay, there are a couple of other wallets also, but these fall into basically two categories: deterministic and non-deterministic. Just let me know, is everybody following me right now? Are the wallets secure enough to keep the private key? Yeah, these wallets are secure, and I'm not saying that absolutely secure, but yeah, these wallets are secure sometimes, and sometimes they are not. Like when I chose, let's say for example, when I chose like 6 words, then these things appear, but it is saying that less than 12 word has low entropy and maybe guessed. So this is a thing, but there are a couple of things through which we can actually make this more and more secure. Let's say, for example, even though they are so I'm giving a phrase, I'm calling it like upgrade, and this seed will change. And but just introducing one word here, which can be called as phrase or passphrase, this thing has completely changed, or this number has completely changed, and this number actually leads to a very uh, you know uh, okay. So do non-deterministic wallet have mnemonic? No, I told you guys, non-deterministic wallet don't have a mnemonic key because they are not going to be generated again. Every time you are using these words and this password, you are going to get this. That's why it is called deterministic. But non-deterministic are so random that they cannot be regenerated. That's why should we pay for owning a wallet? If you are saving something which is worth that money, or maybe more, or which has more worth than money, then you should be paying for owning a wallet. But that's altogether a different story. We will talk about it in more detail when we talk about wallets in more details. Like once you have developed your understanding for blockchain, way too much. Okay. So this is about wallets. Okay. So these wallets actually come in, private key and public key pair. So if you see that just by, this is just the address which you see in the Bitcoin address. Let's say if we are talking about Ethereum, and I'm changing this to Ethereum, let's wait, ETH, is it? Okay. So if you change this to Ethereum, then Ethereum address will look something like this. So you guys have seen Ethereum addresses, am I right? Okay, no problem. So if you haven't seen that, the main characteristic of Ethereum address is this 0x. It is a hexadecimal representation of your, public key, because this public key and these three things, like your address, your public key, and private key, and these are actually unique pairs or unique combinations, which always exist as as ordered pair, if you can call it that, as ordered pair. With this private key, you are always going to get this public key and this address. This is kind of, we have made sure that algorithmically that this happens every time. Why? Because let's say this is this is a very large number. You do some operations on that, and this gives you this public key. And the this public key is more like it cannot be generated without this private key. So the operations which are done on this private key to get the public key are actually very specific, and it depends upon the algorithm which we are using. The example of these algorithms are the one which is used in Bitcoin is SECP 256K1. This is the algorithm which is used in Bitcoin to determine, private key to public key. It is elliptical curve equation algorithm, but if you just keep it in mind, okay. So what does it means to perform operations on private key? I mean, can you give you an example? I would love to give you an example, but the thing is, it will actually, expand. I'll see, like if it is covered over here, then I'll try to give example, because this thing is very interesting. It requires a lot of time for to understand. So when we meet in some other class, I'll try to cover that up. We'll be meeting a lot, okay? So don't worry about that. We'll be meeting a lot, and we will be talking about this, because this is totally different from our what operations we talk about. These are kind of mathematical operations, but these are not exactly mathematical equations. Okay, hold on to that. We'll get back on this topic. And we have lots and lots of explanation to do, like our entire blockchain is going to be based around this only. In some way or the other, you have to see this public key and private key every time. That's why it is being introduced to you in the first interaction. Are we clear on it, guys? Don't worry about it. You will see this thing every time. Public key and private key. If you are talking about Hyperledger, if you are talking about Bitcoin, whatever platform you are talking about, you will know, you will hear about this thing. Okay? So this was a basic thing about the wallet which we have done. So, let's talk about, you guys are here. So let's talk about a little bit about the blockchain. How blockchain works. Why do we have multiple pairs? We will talk about it. Muzammil, we will talk about this in later stage, because these things are actually very interesting. Okay. So, okay, guys, let's take 10 minutes break. Okay, and then we will continue after that, because so far we have, we have covered a very important topic. Let's take a break, and then we will be back at sharp at 3:10. Okay. Thank you, guys. Hello, everyone. Welcome back. I hope everyone is here right now. That's cool. So, is my screen visible, guys? Just let me know. So let's start with enough of the theoretical stuff. Let's see things in action. Okay. So we have heard about private key and the public key in blockchain. There is one very important thing which is called hashing. Okay, hashing is kind of generating a number. Okay, again, it's a number, it's a hexadecimal number. So it takes whatever length of data you can have. Okay, like let's say for example, and you see like this thing actually changes whenever I am changing this value. Let's say my name is Shantanu. Okay, I have spelled one H as capital. My name remains the same, but let's say if I am changing this C B55 C5, okay, and CEC like 73. I'm going to change this. No, very small change, but this entire thing has changed completely. See, this is called, you can call it like this is signature of this text. Or you can say that this is fingerprint of this text. And if the algorithm used to calculate this fingerprint, if it is well designed, then we are not going to have two texts which can have same fingerprint. Okay. So the idea here is what is SHA 256? SHA 256 means secured hashing algorithm 256 bits. Okay. So we will just, this is an introduction. So we will talk about it over here. Like what is 256 bits? So, this 256 bit again is, it's going to, you are going to, see this 256 bits a lot while you are working on, encryption, hashing, and, these stuff, then you will see 256 bits a lot of time. But hashing and encryption are a bit different. Why they are different? Because encryption is a two-way function. Two-way function means if you have the ciphertext, then there are methodologies through which you can actually get the original text back. But hashing is a bit different. If you have the hash, you cannot unhash it. Okay? So if you have a hash, you cannot unhash it. That's the idea behind this fingerprint. And so you can say that hashing of the of your private key can give your public key. Okay, just there are other operations also, but mostly if we talk about the hashing, then it could be one of them. Okay, so the idea here is we have to have a process which creates, which takes very large amount of data. Let's say, for example, I'm going to open Wikipedia page of computer history. Okay, computer history, and obviously that is going to be a Wikipedia page. Just bear with me, guys. I am going to do, Command A, Command C. Okay, I got everything over here and I'm going to paste it over here. Like lots and lots of stuff is copied. But you see, again, this hash size remains the same. So, if you want to understand how big this, this text size can be, it's basically 256 bits. Okay, so 256 bits is actually very very large. And if we talk about, let's say we talk about it in KB. Okay. So what is the size of text in KB? So it is going to be like just divided by 8. You will get KB. So, if we talk, okay, so what we will do is we have to, keep this a bit simple over here uh, right now because there is a lot to cover. Okay, so, so whatever is there in this system, it is going to be converted to your 256 bits. That's it. It could be huge. You can take it very large, but still it is going to be converted to about your 32 byte. So that's just an example of hashing. Okay. So don't worry about it. Just it's on the surface as the encryption and all. We will talk about it in more details. But for now, you can take it like this. Like this system is something, some function which actually gives you, a very small text out of a very large text. Okay, but the most important thing about it is if anything in this text change, like this was a very large one, I am changing a small a or I'm adding a comma over here, then you see it has changed completely. This signature has changed completely. Okay, that's the basic idea behind hashing. Okay, so let's talk about what is a block. Okay, you guys must have heard about, there are a couple of things. Okay, so in the beginning, when I was asking about, Bitcoin, so some of you said like mining. How many of you actually know about mining? Mining in sense like how many of you have heard this term in context of blockchain? Mining in context of blockchain. Okay. Those who have said no, so I'll try to explain it to you guys. Okay. What this mining is all about. So let's say this is a block. Okay. And in this block, there is a payload. Payload could be any number. For me, it's my name. Okay. Or maybe, you can say like I am teaching. It's just a text. Okay, what I'm doing right now is I have input this text and see it. There is a hash which is produced. Okay, whatever text I type, that is going to be a text. See? With that text, there is nothing unique about it. It is not going to take much time. Why? Because, obviously it's just hashing and simple hashing and it actually does not has any particular criteria. But what if it is going to have a criteria? So you will wonder, okay, but this will not change. Okay, obviously this will not change. But what if I introduce one more thing into it? Okay, and then I change the hash. See, and nonce is going to be that number. Let's say I'm starting with a number 0. And you see, if I'm changing the number, the hash is actually changing. See? Every time I am changing the number, hash is changing. And let's say my number is 7 over here, it is changing. Okay, I hope everybody can see that. Okay, so, why this number? Actually, we cannot change this text because that's the requirement, that's the payload. But we can change a random number or we can select a random number and we can actually have control over this hash. Okay. But if we talk about nonce, nonce is basically related to difficulty. What is difficulty, you might be wondering. So difficulty is basically number of zeros, preceding zeros in this hash. Because, obviously if I'm not changing the text, but I'm just changing the number. I'm adding more and more values to this number, and you can see like this number is actually changing. That means if I start changing this number, I can get a hash of desired complexity. Then what I'm talking about is, what is complexity? Complexity is basically the number of preceding zeros. Let's say if I'm saying that its complexity is 4, then we have to have 4 zeros. So assuming the complexity is 4, I am going to mine it. Let's see what the hash is nonce is going to be. It will take some time because mining is a process. It is going through all the hashes. Let's wait for it. Actually, in the background, what it is doing is it is actually looking for the the number which can actually gives it complexity 4. And sometimes it very computation intensive. Let's see in whether it is in action here or not. Just hold on. Okay, let me refresh it. I'll try to do a simple stuff, because obviously it needs more time. Just hold on, guys. Okay. Yeah. Exit pages. Reload. This happens because this is highly computation intensive task. Okay, so I'm using a similar payload. And let's do the mining. I'm actually mining it over here. I'm mining this block, the first block. I'm trying to mine it. Okay, I think this is because of my system. It is not suitable for mining. Let's try this online. Okay, I have an online system also. Okay, so so let's because this system is online, this is not related to my system, so I am just trying to mine it from here. It will take time, believe me guys, it will take time because it is trying to calculate a particular complexity. Okay, how you will know that it is taking more time? Like you will see this number is going to be really very large. Because what it is doing is, it is actually starting from, like the idea here is, wait, now I have to wait. Because obviously it will take time to mine this block. So the idea here is, if we talk about like, if the complexity is 4, the number is going to be somewhere between, it is going to be somewhere like 17 lakh, 18 lakh, 19 lakh or something, but it starts from like 1. See, we have waited and it gives you 1,64,888. Remember this number, because when next time you are going to compute this, let's say I'm changing it, I'm not sure, because the next time when I'm calculating the the nonce, this could be more than the previous one or less than the previous one. But again, this is going to be a finite time. It is not like, an infinite time. It is going to take lots and lots of time. No, it is going to be a finite time. Wait for it. It will give you result. Because why it is taking time? It is taking time, guys, because it is actually starting from, let's say, 1, and it is actually reaching up to the point which we have seen over here. See, it will take time. If it is taking more time than the previous one, that means, okay, we will do a little experiment over here. Okay, I'm going to use my stopwatch. Okay, and I'll try to give you the exact time for this. Wait for it. I'll do the mining because obviously we have to see this thing in action. Like, if it is taking more time, because it has not, asked for, crash. Because sometimes, when we are mining in JavaScript like this, actually program crashes, the browser crashes because it has given a very limited size to our, to our application. So, it crashes, but it is very highly computation intensive task. You guys can actually do this thing at your system also. See, now the number is much larger. Okay. So just I'm going to do a little experiment over here. Okay. You can go for this website also. Now I'm going for the previous one. Okay. And I will start the stopwatch as soon as I start mining. Okay. This is mine. Okay. I have started my stopwatch and it will take a finite time, and I am actually looking forward to, see how much time is it going to take so that we can actually compare. Wait for it. It's still going on. It is still going on. Okay. Done on your page. How much time do you see? Okay. It took 2 seconds. I don't know why it is taking more than this on my system. I'm not sure. But anyway, it depends upon the computation. That's the lesson for this. Because, it depends upon the computation, what kind of, device you are using. It totally device dependent. For me, it is still, like 56 seconds have passed and it is still showing. But the thing is okay, now do one thing, share your hash for the next one. Okay. For me, I'm just, okay. If you guys have a stopwatch in your mobile phones, just try to, give me the exact seconds also, because that is going to be different. As you can see, like it is different for different person. But I'm giving this text. This is a demo for mining. Okay. Use this text directly. Okay. And mine it and give me the hash. Come on, guys. Hash and nonce both. Or maybe you can add time also. Hash, nonce, time. This is the text. I am sending you guys this text. Okay. Give me hash, nonce, and text. And sorry, not the text, the time. If you have a stopwatch, use your stopwatch. Okay, I got a nonce. Okay, in 2 seconds. Okay, come on, guys. Come on, others. If you can do it, just do it. See, you guys are computing on different computers. But still, you can see there is the same hash. Okay, what if I tell you, like, it won't take much time in my system now. Since I can see, that you guys have given me a result. So what I'm going to do is 49736. See, my system computed instantly. The only problem was when I was trying to solve this problem by iteration. Okay, so the first person who came up with this hash can be a block creator, because once he has published the block number, Others can simply copy it. Let's say I am mining in a grad. Okay. Now just add this new text and give me the hash, and I'll show you what I'm talking about. What's the nonce? I need nonce also. This nonce is different. See, it's 62,114. Okay. But you will see that this, once this has been published, like if someone among you is able to publish, you don't need to do anything actually. You can just check whether it is working or not. See, it is working. So, it is mined only if it is coming for the first time. That's the reason we call it mining. Otherwise, it is not mined at all. How you, and now the question will come, how would you know that this is actually, mined? For that, we have to understand the concept of blockchain. This is about, like if we talk about block, it can be, this is a demo for block. Okay. We can see how block can be created. But the real problem is, how do we know that the person who is claiming to mine it has actually mined it? See, that's the question. I hope you understood. Like, the question you guys are asking is a very legitimate question. But there is one more question in between. I'll try to answer that also. How do we come to know that the nonce will generate how many, preceding zeros? So that's the configuration in this system. Okay. Through which you can actually, let's say I am going to do this. Okay. Let's say I'm using this one. Okay. Let's mine this. Let's see how much time is it going to take. Okay. See, mine. Lots of programs are running on my system, so I'm sure it is taking more time too. It will take time. I know it. But when I use this magic trick, okay, so I got it mined. So what we have here is, it's my system. Now I'm going to do one small change. Okay, so you guys will know what this change is going to be. So public CD, just bear with me. Okay, what difficulty is? Just hold on, guys. I'm doing one simple configuration. So, mesh difficulty. Okay, that's difficulty. Okay, hit the bottom, continue at top, difficulty where difficulty equals to 4. Okay, I'm going to make it R3. Okay, and I'm going to run that command again. Just hold on, just bear with me, guys. I'm doing some little bit changes over here in the program. Okay, so it is npm start. Hope this will run. Okay. So, guys, now this thing is going to be a bit different because I am refreshing this page. What happened? It was supposed to change the hash. I changed the hash. So let me check whether it has changed or not. Yeah. See, there is a change over here. Like, we have seen this, this number is like 3 only. Why? Because in the configuration itself, I changed the number or changed the difficulty to be 3 now. But you'll see like this will become faster. But again, it is independent of what we are putting over here. Let's say I'm going to mine this. Okay. Earlier we have mined it with difficulty 4. See, instantly it happened. 3 difficulty and 4 difficulty. You see the nonce, the number of nonce is increasing. Okay. I'm going to give you an example of 5 difficulty also. Okay. Just bear with me. It will take some time because now it is going to be an actual challenge. Okay. Just hold on. I'm going to change this to be, let's say 5. And okay, in my program, whatever I have on my local host, I am going to run that program with more difficulty. Okay, so you will see like the same text, this same text is going to take more time. Okay, just bear with me. Mine. Uh-oh, again. I think there was a problem. I might not have changed. Just hold on. Just hold on. Let it reload. It will take time and it will reload. Okay, it reloaded it, and I am pasting it again and wait for it because you have to wait a little longer this time because now the difficulty has been increased. So you see, like the time which is required to actually, mine this block. Okay, it changes with difficulty. It actually changes with difficulty. So, there is a basic idea, if we talk about this difficulty. So, the idea is if we, if maximum nonce, we set like, maximum nonce, we can set minimum nonce also. So, if we are talking about, a nonce, let's say it's like between 10 to the power 5 or 10 to the power 6, that means in lakh, then it is actually easy to mine. But if as and when if we increase the nonce or increase the difficulty, it becomes more and more difficult to mine. So the timing in blockchain is managed by this this phenomena by adjusting the difficulty. Okay, now there is a question here. I can see, just hold on. Okay. How do we come to know that a nonce will generate how many preceding zeros? It is the other way around actually. You have to find the nonce which can generate that number of preceding zeros which has been decided by the community. Why? Because sometimes people may have faster computation, or maybe sometimes network may have faster computation if we are talking about Bitcoin blockchain. So in that case, the nonce is adjusted automatically in such a way that it is able to generate, only one block per 10 minutes. This is the nonce which is going to, compute govern that speed of block generation. If you mean that if nonce increases, then the difficulty increases. No, it is other way around. If difficulty is increasing, then nonce is increasing. Okay? Does this answer your question, Praneeth? Nonce is not the requirement. The requirement is difficulty in hash. Okay? If you increase the difficulty. See, I have in the earlier one when I set it to 3. Let's say it is again. It is on the same cache, and it will see it mined immediately. But in case of where is that? Okay, in case of website, if the nonce is 4, it is going to take some time. We have to change the nonce. Yes, you guys are correct here. We have to change the nonce, but difficulty is the requirement. It is not the nonce which is requirement. You have to calculate nonce based on difficulty, not difficulty based on nonce. Are we clear on this? So we are increasing difficulty by just assuming. That's our, or you can say that, okay, we are voting together to assume that, okay, this is going to be the difficulty. Okay, then we fight on calculating the nonce. It is kind of, a goal which we have set, and then we fight on the, we create a race. And then we, you can say that, okay, in 100-meter race, we decide that, okay, that we have to run for 100 meters. Then we fight for who comes first. Okay, this difficulty is exactly the same. It is like it is being it is being set by the community. Like, okay, this hash, this difficulty is going to be X, and then you have to find a nonce for that difficulty. Okay, let's see whether that thing has been solved or not. That is not solved yet, I guess. Nope. What happened with the mining? It took a long time. I'm not sure whether it will be able to mine it or not. Because the thing is, in my program, I actually changed, the difficulty. Actually, in the program which we are using to show the demo, there is a limit. There is this 10 lakh is the limit for, which I had set for my program because it could take infinite time. See, it will keep me waiting. Okay, so let's see. So by far we have understood, like, what the nonce is, how it, it is going to take time. Okay, I have another question. If it is set by the community, then they can vote for less difficulty and get the block mined and then get the reward. So that's the thing. You have to agree. Everyone has to agree for the mining. It is not like, people, if let's say for example, there is kind of voting in which, they went for, smaller difficulty. Okay, what will happen in that case? In that case, someone with, like you can say that, okay, somebody has higher computation power and they will be able to generate the block immediately. Okay, so if this happens, the others who have already voted will actually not be able to sustain, because they have they have voted for it, but somebody else actually who has more hashing power, actually, the sequence of hashes is being generated. It is kind of, number of hashes per second. It is calculated in the hashing power of system is calculated in number of hashes per second. Okay, let's say somebody has higher hash rate, they can calculate faster and the difficulty was set too small, then what will happen? In that case, others will lose the race. So, will you agree to lose the race? No, you won't. So, the idea here is we rely on people doing the hashing at their best speed so that, it depends upon the hash rate of the network. So, one more thing I'd like to give you over there. How would be, like, how are you going to do, like, what do you call it, like mining pool? Mining pool, basically they do is they divide the nonce. Let's say there are two people in the mining pool, and maximum number, the hash which can be calculated in this is like, in a couple of thousands. So what the mining pool will do, they will decide among themselves, okay, I will do from 1 to 10, I will do from 10 to 100 and so on. Okay, and somebody will find the nonce in that pool, because obviously the division of the range depends upon the members of the mining pool. So they have divided and somebody got the number, the nonce, and they published the block. Then the block reward will be distributed among all the members of the mining pool. So this is, how it is not like, you have to do that individually. You can actually create pools of, multiple computers, and, you can do like, somebody is doing 1 to 1000, somebody is doing 1000 to 2000, somebody else is doing 2000 to 3000, and so on. It does not depend on your computation, but rather on the network. So, it is not a thing which can be, managed by a group only, because if they have higher computation power, they can generate blocks, faster. See, so, those who have slower computation rate, they will, obviously, if it is a blockchain, then everybody is running a node, everybody is trying to win. And if there is only one person who is winning, then it is time to change the difficulty. So I'm coming to your question, so we can say that for a difficulty 3, it can have greater nonce value. No, it can have, but it is highly unlikely. As and when we increase the difficulty, the size of nonce increases. That's the thing with difficulty. If we increase the if we increase the difficulty, then the nonce will increase. Okay, this is how things are related. So I hope I have answered all the questions so far. Okay, we have one more question. Then where will we use the nonce value? We don't use the nonce value. We just keep the nonce value as a data in block. Okay. So the idea here is, when you are using a nonce value, you are going to, publish it to everyone. When it is a blockchain, then what you do is you create the next block. Okay, and then tell it to everyone. So, it is not like you are creating the first block only, then you have the ability to create the next block also. Because once you have, published your blocks, then others will verify. And once it has been verified, your blocks will be accepted. Okay? Then only you will be, if preceding 0 increase in the hash, then does it mean that difficulty is increasing? No, it is not the same, it is not the same story. Difficulty is not for one block, it is for a couple of blocks. So if you can see, like, there is, sometimes it might happen that, without introducing a larger value of nonce, you can get the hash of particular difficulty, or maybe without any nonce at all. So, in legit mining systems, the nonce range as well as the difficulty, both are decided. Okay? So you need not to worry about that. We will, you can dig deeper into it, like, know how nonce is calculated, how mining is done. But this is the basic stuff. Okay? It is, the idea here is the difficulty should be the one which has been agreed upon by the community. Okay? And the nonce should be of that particular range. Okay? Doesn't nonce be stored in the hash header in case of using the hash? So basically what we do is now it's the right time that we can move on to our blockchain rather than just using one block. Okay? Let's move on to blockchain. Any questions so far regarding this? Because Praneeth, your question will be answered in the next phase when we see the blockchain. Okay. So, guys, I hope I have answered all of your questions so far. Okay, you need not to worry about the difficulty right now, because this difficulty we will it is like it's a demo program which I am using, and I am setting difficulty in that. But if we are talking about the real life mining in Bitcoin, then it is set by the community. Okay, and it is set in the program. It is kind of automatically, difficulty is proposed and then it is accepted by a number of people, then it becomes the standard for that block. This is how it happens. And basically it is designed in such a way that if you get the net hashing power of the network, if the hashing power increases, the difficulty increases. And okay, I'll show you an interesting thing over here. Okay, and that is hash rate chart of Bitcoin. Let's see what is the total hash rate, and you can see, like, this is the hash rate, like, it is in terahash. Okay, it is not hash, it is in terahash. So 100 m terahash, this is like, this is a something for a scale. And if we talk about like all time, see, initially in up there in 2000 up to 2017, early 2017, it was significant, but it was not much higher. But you can see, like, it is continuously increasing. In case of 2021, you will see, like, it has seen a phenomenal rate. Okay, so let's this is the hash rate. Okay, but let's talk about difficulty also, because I told you guys. So Bitcoin difficulty chart, network difficulty blockchain chart, and where is that? Okay, it is there in the same page. Sorry, my bad. Network difficulty C. I am putting network difficulty, and that to all time, just because for simplicity. You will see, like, it has common trend. See, network difficulty is kind of similar to that of our hash rate. And guys, I'm not diving much deep into it, just for the sake of understanding right now. You can just see both the hash rates are the network difficulty as well as total hash rate of the network are actually in sync. Okay, are we clear on this, guys? You can do your own research from now. I'm just laying down the foundation so that you can, actually do your research. When using 256, that is their way to find the number of characters in the code generated. Now I will put a halt to this, and actually, if you want to dive deep into this mining and all, technically, then obviously there is a lot of stuff already. I have just laid the foundation to it. There are a lot of other foundations which are required to be laid. So let's move ahead with that. Okay, Mohit? Okay. Because, this is not going to end. We are going to have lots of interaction. But still, we will not be able to answer everything. Okay? We have to, like the foundation has been laid. Now you can you can if that intrigues you, or if you find this interesting, just go ahead and find it. You can start your own quest of excellence in blockchain. That's the idea over here. Okay, so let's take example of our blockchain. Okay, so that's the problem. Just it will not work because, okay, let me reset the value for difficulty, because I have actually just hold on. I'm just going to edit it. Just hold on, guys. I'm going to make it like maybe 5. No, 4. Okay. Team start. And by the way, this is just a small Node.js program which I am using for this demo. I am refresh this page. Okay. See, now the difficulty has been changed to 4 again. So this is how a typical blockchain would look like. So see, there is a block 1, there is block 2, then there is block 3, then there is block 4, and there is block 5, and so on. But there is a very particular thing about this. This block has a previous hash of 0. Why? Because there is no preceding block to this. So this block is called a genesis block. Okay? But every subsequent block is going to have the hash of the previous block. Okay? See, this hash is same as this hash. This hash and this hash are same. And the particular, a very special thing about it is, if you change the hash of previous block or nonce or data, this blockchain will change. Okay, let's say for example I'm using, okay, my name is Shantanu, I'm using this. See, so everything has changed. I've just changed the data. Let me mine it. I'm sure this is going to take time, obviously. See, now it has been, oh. Looks like the difficulty is still 5. I changed it, but still it is showing 5. But anyway, that's good actually. Or maybe not. I'm not sure whether the difficulty is 5. Let's mine another block, and then we will see whether the difficulty is 5 or what. Because, as I told you, somebody asked the question, like, how this, what if the block, what if the number which we are getting is more than, or because obviously we cannot have less than 4 if we have set the difficulty to 4. But if it is more than 4, we have to check whether the difficulty is 5 or whatever the number is or not. I'll mine it and then see, because I cannot assume anything. Just hold on, guys. It will take time. Bear with me because I have been fiddling with it, so it is kind of changed. If it is 4 again, then it will give me 4. No doubt about it. But if it is 5, then it is going to take time and it is going to give me 5. And I hope it is not 5, because obviously it is going to take more time. Yep, it looks like. Wait for it a little bit more. Okay. No, lucky for us, it is not 5, it is still 4. Okay. So you see, like, I'm going to mine all the other blocks. Okay. I'm going to mine this. I cannot mine this right away because this hash is going to be used in this. So it is stopping me from mining other blocks. Wait for it so that I am able to mine all the blocks. Then I'll show you a demo of why the blockchain is so special. Wait for it. Okay, these are multiple nodes which can create a block. Then it is, no, these are basically blocks itself. Okay, in this demo, these are blocks itself. Now coming back to your question, there are multiple nodes which can create a block. How it is ensured that valid transaction blocks are added in same sequence. Otherwise, it will change the blockchain as well. Yes, 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 yes. So the idea here is of, the core idea behind this is to have the longest chain. Okay, and then validate it. Once the Genesis block has been created, there are a couple of people at that time. Then, as and when the system network grows, there are more and more people to it. So, if you want to be a participant of the network, or if you want to add the new block, then what you have to do, you have to use hash of the previous block. Then only you can add your new block. Am I right? See, here you are using the previous block. So if this previous block points to X, then this is going to be a branch of that X. And so it has to point to the previous block, and this one has to point to its previous block. Then this one has to point to its previous block. So in this way, this chain is created. And if anybody wants to add to it, let's say they decided, okay, I will create my own chain. It will remain as a chain, and the system, if it is being validated by others, it will be denied by them. Okay, because let's say Genesis block is created and the first block is created. Once the first block is created, the second block is going to be based on the address of the first block. Then when third is created, it is going to be based on address of the previous block, and so on. So we have to have the chain which is accepted by all, because this chain is going to reside in every participant machine. Okay, once we have that set up, we will, while you are validating it, you will check the copy from yours. Like, let's say you have 4 blocks, okay, and you want to download the 5th block because you have not mined it, you are just downloading it. So what you will do, you will check for the address of your, okay, what happened? Okay, yeah, it was mined. I thought it was not mined. Okay, so, okay, in the 3rd block we can't, oh, sorry for that, it is mined. See, in 3rd block it is there. Actually, while I was scrolling, I got, I by mistake scrolled that also. It is there. It is there. In the 3rd chain, you can see. Okay? Yeah. It happens. It happens. It's very large number, so it happens. So the thing here is, If you are about to download the fifth block, then you will check the hash of the fourth block you have. It has to be there in the previous block, or the previous block hash area, or previous block hash value of the next block. Then only you will download it. Otherwise, why would you download it, or why would you be a participant of a fake network? Because you are actually spending your money or whatever over here. Till this you have done that. What if you you download others block and it is not accepted? That your bandwidth, your time, everything will be wasted. And even if you try to create the next block, it will not be accepted. That's the reason we it is kind of, if you want to lose, you are most welcome to download or create whatever blocks you want, because that is not going to be accepted by others, because others have their own copy which is widely accepted. That's why we call it like we have a consensus over here that, okay, this is the chain which is accepted and we are going to use it. Okay, so this is how our basic blockchain works. So now coming to attacks on blockchain, there is one thing which is called Sybil attack or Sybil attack. You can call it Sybil attack, somebody call it Sybil attack. What kind of data is added to Bitcoin blockchain? Okay, any kind of account informations are added to the Bitcoin blockchain, like the values associated with all the addresses and transactions. We don't want to go deep into it, because this is just the basic part. Okay, we may try to sort this out in some other session. Okay, for now on, let's talk about the attacks or vulnerabilities. There is a thing called Sybil attack. Okay, what is Sybil attack? Sybil attack is basically kind of, you have multiple accounts and you want to overwhelm the system, because in this system, if we have multiple nodes, then the legitimacy of the block is decided by the the nodes which are actually participating in that network. But in case of apart from this, if the blockchain is there, this is going to be signed by an account. If we are talking about real blockchain, and that is called that is basically the one who has created the block, or signed or mined the transaction. That's the basic idea behind that. So let's say somebody created this block, okay, and for it has to be accepted by others. So it is going to be like they have to validate the transactions or validate the block. Now we have the validators also. Once we have the validators, the block becomes valid, the reward is distributed. Okay, what if somebody has majority of accounts? Okay, what if somebody has majority of accounts and they accept the blocks accordingly? So in case of proof of work mining, which we have discussed so far, what will happen? Because it does not matter. It does not matter how many accounts you have, but it depends on what is your computation. Okay, once the computation of network has increased, the network will increase the difficulty, and again the system will be balanced. In this way, in proof of work algorithm, Sybil attack is managed. Otherwise, let's say if it is not there, if this phenomena is not there, like let's say there are 100 people, out of 100 people, 50 are accounts, or 51 account is owned by same person. Because you can create any number of account on your own. See, these are legit accounts. These are all legit accounts. I can create any number of accounts I want. Okay, so in case of algorithm, in case of our consensus algorithm, which is proof of work here, it is like we have a consensus. Or we can say that okay, if this thing happens, this kind of thing happens, then the network will look for computation power rather than for a person. Okay, so in that case, you have to win that part also. It is not like, you are going to, it is going to be signed by same number of persons. So, it becomes difficult. I'm not saying it is impossible, but yeah, it is kind of impossible because the network will adjust itself. Okay, network means all the participant nodes, all the, the programs which are, mining, they will adjust. Are we clear on this, guys? Regarding civil attack basics? If you have any question, just ask me. Regarding civil attack. Okay. So we can talk about 51% attack also, because obviously if somebody has 51% computation of the network, how it could be, like I told you, like if there is a very large mining pool which has the power of 51% of entire computation. So you might be wondering, okay, it is about an individual computation. No, this 51% is basically the network hash rate. If somebody owns 51% of network hash rate, then they can actually beat everyone else in calculation of the norms. Then it is not like an individual person has to be like that. It could be a large mining pool also. So, so the idea of Bitcoin is actually, fighting with this 51% attack all the time. So in this way, people are trying to, distribute the network as much as possible so that there is no aggregated, hashing power. But it is there. We cannot stop it because people can buy, machines and, do that mining. We cannot stop them. So, but people are trying to actually make it as decentralized as possible. Right now, we are, we are fighting with this 51% attack. And to be very frank, never, ever, it has happened in the history of Bitcoin. Because the network adjusts itself. There are chances that it can happen in future, but most of the time, it is like, the network is always the winner. Okay? So this was about, our, how, okay. Now let's take example of phishing attack also. How do we know it's happening? So it's happening, you cannot know it's happening, but only the participant of network will know it is happening, because it will, if somebody has 51%, let's say for example, how we actually detect an attack. We detect an attack based on its effect. Whatever effect is there, based on that, we say that, okay, this network has been attacked. So if it is a 51% attack, what will happen? The mining reward will go to one particular user pool. Okay, because they may be having the largest, hashing power. So maybe to some particular user. So in that case, others who are participant on the network will see, because they are actually losing it. Other participants are losing, so they will, adjust the hash rate accordingly so that that particular group can actually be like, beaten. Because, there is no coming back. Even if there is a 51% attack for one block, two block, it doesn't matter, because only one kind of, mining reward is, only one mining reward is distributed. But if it takes place for larger number, then there is a problem. And then, but by the time the network would have adjusted itself with the difficulty, so that network, that network size 51% is manageable. Okay, so the question is, if 51% is identified by network and accordingly difficulty level increases, the combat, even in the case, will not be benefited because their hash per second is already poor. No, it is not like that. This is, the idea is not to reward everyone. This is not, a democracy. If you have hashing power, then you will get the reward. That's it. If you feel like, somebody is lagging behind and, you should reward them too, this is not the case here. In 51% attack, what they try to do is they try to change the values of the previous hashes. But again, even in the case of 51% attack, it has to be validated. Like it has to be managed, approved by other blocks also. And you see, it is not like, every blockchain is getting the same, like, let's say there are 100 people. So not everyone is getting, it is not like, other will stay silent, okay, you mine it, I'll not do anything. Once they receive that hash, they will, they will try to create the next block. It is kind of like everybody is running for that race, okay? And if there is an attack, they will actually detect it because it has to be validated by at least 6 members. So once it is found out, then it will not be accepted. Because you might be wondering why. It is because that network is working something. That network is doing some work just to get rewards, and if it is getting, if they are getting scammed by someone, why would they accept it? So even if 51% attack is successful, its success is diminished just because there are lots and lots of people already there in the network. And the most important thing is, if the hash rate is poor, then don't do it. It is not feasible for you. Like, let's say, for example, in PCs, like in my PC, what if I, start mining Bitcoin in my PC and I'll start saying, okay, I need Bitcoin because I'm mining. No, it is not my right. Bitcoin is not your right. If you have computation, go for it. Otherwise, just stay idle. Find another way. Okay? So, like, let's talk about phishing attack. Phishing attack is basically, you have a wallet, okay? And you are kind of, phishing attack is very simple, like, the usual phishing stuff. People are saying that, okay, this is, if you want to recover your wallet, you have to enter your passphrase over here, and you put your passphrase, and bam, your whatever is there in your wallet is gone. This is how a phishing attack works. This is like, when you have a wallet, treat it like, it is your bank account. Never share details with anyone. Okay? So that's the idea behind, the phishing attack. You don't get scammed if you have some, your private. Basically, what they try to do is they send you fake request, and based on that, they try to get your private key. And what's the best way to, not to give the private key or not to leak the private key? Don't do it. Until and unless you are sure, 100% sure that this is a legit system, go for it. Otherwise, don't go for it. Okay? As and when you understand about blockchain and, stuff, and you will think about it, you will design on the system, work on the system, then you will know that there are a couple of ways through which actually you can mitigate or, avoid these attacks. Okay? So let's take example of Government of India's approach. Okay, that's very important because that's a very talked upon topic right now. Okay, just hold on. Let me open that page. Actually, it's a documentation. Okay. The idea is very fantastic, if we talk about, blockchain. But the thing is, our government is quite skeptical about the cryptocurrency. So this is the document, Okay, I'm sharing the link with you guys so that you can also have it. This is the link. Okay, and you can go through it. Okay, this is about the and I'm sharing this right away because this could change. There are a lot of things going on in blockchain. Uh, uh, you know which actually might be India in RBI might be coming up with their own cryptocurrency or something. So it is, you can see, like, it is the draft discussion paper. This is a draft, like it is not the finalized one, it is not the law, it is just a part of blockchain strategy, and you will find a lot of things into this which are actually related to that. And what it is focused on. Why do we need blockchain? Where we need blockchain? We need blockchain where we need trust. Okay, it emphasizes on this trust paradigm, which is basically the crux of every system which is using the blockchain. Okay, we have seen like how the trust was established in a distributed system in which non-trusting people are existing. Have we seen that? Like in the mining. Okay, it is true RBI wants to have a cryptocurrency. Yeah, like I'm not the right person until and unless the government gives something in the form of law. There are a lot of speculations going on regarding that. Okay, but this document will give you a brief idea of how the thing is going on, because this is already a year old document. So I can say that this can give you idea of government approach on blockchain. It is not on government approach of cryptocurrency and bitcoins. Okay, so go through it, and there is very important section in this where it gives you a idea of how to use, how to decide whether the problem is solvable by blockchain or not. It actually, this on page number, what I should say, page number 20, this diagram actually gives you a brief understanding of how to check whether a use case is a blockchain use case or not. Okay, yeah, blockchain is fine. Blockchain, every government is actually working on it. I remember Telangana government, Kerala government, they have their own strategy for blockchain. And it is like, when you want to okay, so it is a greenfield. Greenfield means like people are actually trying to prove the potential of their idea. Okay, if you have some idea, you can actually work upon it and go to those government and get funding. That's why I'm trying to, introduce you guys to this blockchain stuff. Go through this document and you will understand in great detail like what is the thought process of the government. It could be any government. It is not like the central government only. It is basically the thought process of every government in India right now. Again, it depends upon individual to individual, but yeah, governments are trying to solve some problems based on that. Okay, so go through it. If you have any difficulty, and it is a very simplified document. It is not like once you have the basics, your basics ready, you will see like you can understand this document well. Okay. We have actually tried to cover a lot of basic stuff over here. Otherwise, since it is kind of a source document, you can go through it, you can read it any number of time you want, and you can have the rough idea. And I'm not going through it in step by step. Okay, so let's take an example of trust over blockchain. Okay, so how to create trust over blockchain? So you see, like there are two people like Ram and Shyam, and they have it's a very common story in our day-to-day life. This guy Ram is actually a professional service provider. He provides some service to Shyam, and he is expecting some money in return of that. Okay, because this happens all the time. It could be your vegetable vendor, it could be your employer also. So what kind of trust we are looking for here? So we are looking for something which is kind of, we assume that it is inherent. First of all, if it is a kind of professional service, the money has to be paid, and then you have to make sure that that currency is real. Okay. Then, in case of, once the payment has been done, it should be provided with a receipt which is irrefutable. Let's say it is the salary, and if you are provided with the salary, in your bank account, you cannot deny it because there is an evidence for that. Okay, so let's say if it is a blockchain kind of stuff, so they so the thing is, this actually is very crucial. We assume that it is there, but there are a lot of systems which exist for that. I'm not saying that the Bitcoin is the only solution. I am trying to give here like how the trust is created over blockchain. Okay, don't assume that this is the solution which can be done on Bitcoin only or blockchain only. Okay, so how we are going to solve it through blockchain? If it is blockchain, then you can create transparency and immutability in case of ID of the currency, or maybe you can keep record of origin of the currency. So, or whatever changes has happened, you can keep record of that. And then for irrefutable receipt, you can include verifiable proof or auditable proof. Okay, in this way, you guys will be able to actually, create kind of trust in the system. Like if you have these features, then people can actually come to your system and do these kind of transactions. Okay, so how many of you guys have heard about digital signatures? How many of you have seen a digital signature? How does it look like? I told you guys earlier that a digital signature, sorry, I told you guys when I was talking about the private key and public key that we will always come across those. Okay. So a digital signature is basically your public key. Or, it's a combination in which the most important part is your public key. How a simple digital signature or a digital certificate will look like, I can give you an example. I am opening HDFC Bank site. Just hold on. And a typical certificate will look like this. How it will look like? See, now I'm going through the details. Aadhaar is not a digital signature. It's your identification. Okay, it's not a digital certificate. It's okay, or a signature. Signature is a bit different. What a digital signature does is a digital signature actually ensures that you own the private key. No, the QR code are basically you can say that yes, QR code is your digital signature. yes. QR code can be called as your digital signature, but it is by definition it is kind of a representation only. Okay, that QR code might contain your QR code is basically a quick response code. That's it. But it has to be a public key which is associated with your account. Then only it is a digital signature. Okay, Praneet? The QR code in itself is not a signature, but it can be if it has some associated value to it. Okay, QR code is just a quick response code. That's it. It could be a very small one. It could be a very big one. So your digital signature is basically, in term of public-private key. Okay, then your bank account number is not your digital signature. Okay, so let's talk about digital signature. And for digital signature, we have a story over here. Okay, so me, like Shantanu Chandra, is showing you this picture and saying Ram has, made a statement that Sham is my friend. Okay, so this is just a thing. I am a third party. These are two parties, and I am saying that party A or party R has given a statement regarding party B. So you will be trusting it right away, but why would you trust it? Don't just assume things. There is a trust problem in this statement. I'm a third party, I'm giving you this scenario. It could be having some problem. The problem is if I'm saying that it is Ram, then is it really Ram or somebody else? Is it what the Ram has stated? Like, is it the actual word which was said by him? Or is this really said by Ram? Like, first of all, if I am saying that this is Ram, this could be anyone. This could be Manoj, this could be Sham, this could be Ramiz or anybody else. Okay. So this text could also change. This person could also change. So, we have to first establish the identity of this person, then establish the legitimacy of this text, and there has to be an association between this person and this text. Have you understood this problem? What we are looking for, identity of this person, legitimacy of text, and association between identity and this legitimacy. It's very simple. Let's make it. Okay, this is what I'm doing, Praneeth. In this situation, we have our person. First, we have to establish the identity of this person, whether this person is the one me or I'm claiming him to be, or is this the real text, or how would you believe that this is exactly what the person has said? Okay, so first of all, we have to create an infrastructure where Ram's signature is validated. That means the public key of Ram is established. Public key has to be shared with you, me, and everyone else. Then only you can say that, okay, this person is Ram, because that identity has to be established first. And that identity can be established by using the public key. Okay. So email ID, you can call it it can be called as a public key, but it is, in sense, it is not exactly the public key, but yeah, it can be used as metaphorically, it is a public key. Okay. So, first you establish the identity of this person. Then you have to check for the, fingerprint of this text. That means hash of this text. Okay. This person, if this person want to say anything which can be trusted by anyone, first of all, he has to get himself registered in the public key, infrastructure or PKI. Then he has to, create the hash of this text and then sign it digitally or encrypt it. Just encrypt it using his public key. Once he has encrypted using his private key, not the public key, but the private key, then he is going to create a unique text. He got the hash, then he encrypted it using his private key. In this way, he will get a unique text, which is the signature of this text. Because the hash is going to be unique, this public key is going to be unique. Once the person created it could be hashing also, or it could be anything which you want to, even if you want to encrypt it, encryption is a two-way function, so that's fine. If you want a one-way function, also a quick function, then what you can do is take hash of his public key and hash of this text both together, because there is no reversal. Then you can say that, okay, this is what we got. And you did some operation. If you want to validate it, then you have to do some operation, because that digital signature is going to be validated against the public key of the person which is there on the public key infrastructure. That means it is known to everyone that this is the public key. So what you need is hash of this text and public key. Then you can directly say that, okay, if it is true, then this person will be the one who has generated this public key, otherwise somebody else. Okay, this is how we do the basic foundation of or basic layout of a public key. So this is how it is done. This is the person Ellis, and this is the text. They sign it using their private key, and then along with the text, this digital signature is sent across. Once you are verifying it, you need this digital signature and the public key of this person. If it is true, that means message is authentic. Otherwise, it will give you a false result. Are we clear on this, guys? Yeah. In case of email, you can say that password is the private key. Okay, but it is not. It is totally different. Private key is more complex than a password. Okay. Are we clear on this, guys? Yeah, metaphorically, to understand, you can say that, okay, yes, this is fine. Username and password, yes. And we have discussed about how we are going to validate the use case. Okay. So, okay, one more thing before, concluding concluding today's lecture, I would like to, have one more thing, which is called UTXO. When you talk about Bitcoin, then you will hear a lot about UTXOs. So what is a UTXO basically? UTXO is called unspent transaction output. TX is for transaction, U is for unspent, and O is for output. So if we talk about UTXO, we are talking about unspent transaction output. So you might be wondering, what is that? So unspent transaction output is basically a value, okay, which is associated with a public key, okay, and it actually forms part of your Bitcoin balance. Okay, how it happens? It is more like, a divisible currency note. Okay, it can be, you can say that, okay, it is a divisible currency note in which the smallest unit is 1 Satoshi. Satoshi is the smallest unit of Bitcoin. Okay, so let's say now I am trying to metaphorically compare it with the current transactions. Let's say you have not 1,000 but 500 rupees note. Okay, and you want to buy something which is 250 rupees. You cannot, just tear your currency note and give it that half to that person and take half to yourself. No, you have to give your entire currency note to that person, and in return, that person is going to give you a different currency note set, maybe hundreds, or maybe in 50s, maybe in tens. Okay, but in Bitcoin story, what will happen if you have 500 Bitcoin and you want to transfer 250 Bitcoin to some other person, then you have to actually do it in this way. You have to create a transaction. Sorry, you have to create two transactions. The first transaction is going to transfer 250 rupees to other person's account, and the second transaction is going to transfer 250 rupees to your account. That means the remaining balance has to be transferred to your account. Okay, in that case, you have an unspent transaction output of 250 rupees. Earlier, you had unspent transaction amount of 500 Bitcoin, not rupees, but Bitcoin. So what the idea here is, whatever transaction you have got in your wallet, it has to be uniquely generated by some previous transaction. Okay, that previous transaction, that result of that previous transaction is called unspent transaction output. Are we clear on this, guys? Okay, great. That's great. So, guys, I'm going to, publish a poll, just end session poll. Just fill it right away. Okay. Then we have one more topic, and then we will conclude it. Okay. I have published this poll. Please, uh, enter your opinion into it and whatever. Okay. Just do it quickly so that we can cover our last topic which we have for today. Come on, guys, make it quick. Nobody has submitted it so far. Come on. Come on, guys, fill all the forms. We don't have much time over here. Still, majority of polls are not done yet. Please get it done. Couple of more, please. Come on, guys. I hope this was an interesting session for everyone. I think 2 or 3 more are left. Just get it over with, or I'm going to just stop publishing it because we have a topic to cover. Okay, I can live with that. Thank you, guys. Thank you for your opinion. Just okay. So, guys, one more thing is left right now. So, obviously, we have a lot which is left, but it is going to be a continuous process. So let's before moving ahead, you will hear a lot about public, private, and consortium blockchains. Okay, so these blockchains are going to be based on who is a participant of that network. Okay, by participant means who can view it, who can create a block, who can who can validate a block. Okay, these are the two important phenomena: who can create, who can validate, or who can view the block. Okay, so in public blockchain, anybody can do it. Anybody can read a block. Anybody can create a block. Obviously, it depends upon you can create it, but you have to have to comply the consensus algorithm also, because different consensus algorithm have different requirements. But yes, anybody can participate in that. Then there is the private blockchain. In private blockchain, what happens? Only one person or 2% can allow it. Okay, maybe a company, maybe an organization can allow others to be participant of that. But sometimes there is a consortium blockchain. In consortium blockchain, we have a couple of companies. Let's say TCS and Wipro and Infosys and Accenture came together and they said that, okay, we will start our own blockchain based on consultancy projects and blah blah blah. Whoever is the participant is going to be decided by that consortium. If there is a consortium or a group of person, we call it a consortium blockchain. Okay. Yeah, JP Morgan actually, it is not exactly a consortium blockchain, because consortium blockchain actually depend upon the participants. That means if it is one organization only, we can call it like they have their own crypto. That's fine. That's a different story. But Hyperledger is private and consortium. By this, we mean it depends upon who are the participants. Let's say if one hospital is only using that Hyperledger Fabric network, then that is a private blockchain. If 5 or 10 hospitals are using it, then this Hyperledger can become a consortium blockchain. Okay, and if everybody is using that Hyperledger, then it can become public. Okay, it does not depend upon the tool you are using, but it depends upon how it is being used. Okay, you can call it like, I'm just going to give you a very stupid example for that. It could be like a restroom. If it is public restroom, anybody can use it. If it is in the mall, like a consortium one, only few people who can access the mall or who can enter the mall can use it. If it is a private one, that means in your house, only the private members can access it. I hope this actually clears everything regarding this. Am I right? Thank you, guys. It has been a great session, and we'll be meeting anytime soon. Actually, you won't be getting this deck because that is not of much importance to you guys. But yes, you will be having the recorded session. Okay, that will be very helpful for you guys also if you want to go through it again. And if you want to connect with me directly, my email ID, I'm sharing it. Okay, so if you have anything you want to add, or you have some feedback for that, just connect on this email ID. And if you want to, if you have any doubts which you have not asked here, okay, that is not my call. You have your, you have to connect with your mentor, for student mentor for that. Okay, and if you want to have a class, in which you want, or maybe you want to have a one-to-one session. If you have some problem in your, maybe you are appearing for an interview, or you are having a project or something like that, you can just connect with me one-to-one. Just connect with your student mentor, and she or he, whoever is there, will connect with me directly. Okay. We can have weekday sessions. Usually, I have weekday session for mentorship, one-to-one mentorship. Okay. Thank you, guys. You have been great audience, and it is really fun when you guys are interacting a lot. It's actually fun for me as well. Thank you, guys. Thank you very much. Let me